team? Could you use someone? Or are you the person who needs a team? Let me know your status. At the end of class, if you haven't found a team or you're looking for a team or you're looking for an extra member, I'll ask you to come down here. So please go ahead and click on that at some point as we go. And we'll come back to that. Okay, so while you're getting at that, today we are going to continue talking about Pixi and how it can be used to very quickly spin up prototype web browser-based games or animations and stuff. And then if we get time, we'll start talking about how to deploy on AWS. So the final project, specifications are due today, as are your first progress report. As you're thinking about the specifications, it's up to you to sort of think, what can we do that's cool? You have a lot of freedom here, but you do, with great freedom comes some responsibility. You need to figure out what is something reasonable. We will try to read over your short discussions that you're turning in today about your project, give you some feedback if there's anything that we think is really underscoped or really overscoped. For the most part, most of you are seniors in CS. You sort of know what the expectation is in this class. You've got 4 weeks. We expect something relatively cool. Here's some examples, though, if you're learning the learning outcome tracker. Here's some things that you probably want to add, or some things you might add. For example, saving files. Right now, we just hard-coded files. Obviously, saving files would be a great thing. Some sort of meta-analysis. Right now, we say, how much has a professor completed putting their course together? Well, we just randomly put a little widget up there. It doesn't say anything because we're not computing anything. That would be a nice addition to add. Data analytics. So how many learning outcomes have been covered? How well they've been covered? That sort of thing. Adding some charts, some nice, pie charts and bubble charts and bar charts. Get a charting library and dump it in there and chart some stuff. That would be good. Add search. At the front page, I want to search for, instead of tracking down what Professor Germain is teaching, I want to just search for Germain and it should pop up. Or I want to search for the learning outcome that contains the word security and see how many security learning outcomes are across the entire curriculum. So there's a lot of things you do there. Add program level learning outcomes. So each course has its own learning outcomes, but the School of Computing, the CS degree, has its own learning outcomes for the entire degree, and each of those course level learning outcomes should somehow map to a program level outcome. So these are all sorts of ideas that you could think about adding to your system. Will you add all of them? Probably not. But depending on how much work we do in each area, you could add, quite a bit to each of these things. And there's other areas that you could also work with. Okay. All right, so that's one example if you're doing the learning outcome tracker. If you wanted to do some sort of game, like what complexity, or talking with a group about what complexity of game could you make. Connect 4, seeing as you probably should be able to write that in one day, is probably too small of complexity for what you're looking at. Settlers of Catan, how many people have played Settlers of Catan? Anyone never heard of Settlers of Catan? It started the board game revolution. Google it right now, Settlers of Catan, because if you don't play board games, you should, and it's probably one of the greatest. It's probably at the limit of what you could do, and even then you couldn't do it completely. I mean, you got to fudge a bunch of stuff if you're going to do Settlers of Catan level game. Okay? So Connect 4 too little, Settlers of Catan probably too much, unless you don't want to have weekends or something for the rest of the semester. This should say tower defense. I don't know what I type defines. Tower defense games. I think Peter Jensen in one of his courses has people do a tower defense game. If you wanted to recreate that or do something like that in JavaScript, that also would be really cool. On the back end for a game, again, there has to be a back end on any of these things. keeping track of scores, or maybe players could send notes to each other. Like you beat someone, you send them a mocky notes. Next time they log in, this note pops up and says, "Ha ha, I beat you. See you next week," or something. Putting a game time date scheduler in. That would certainly be, an entire 1 or 2 people's work for the entire project would be like how do you schedule people's times and stuff. Find a JavaScript forum and install it and put the forum in. Normally installing software is not the highest level of achievement, so don't think that my entire thing will be to find someone else's forum and install it. But adding something and then modifying it is certainly worth doing. Adding an AI to your games. So a question was raised a while back, is like, how do we keep people from stealing our JavaScript games? How do we keep them from just taking all our stuff and using it themselves? And one real good way is you put the AI on the server, and anytime a move is made, the server does all the computations, and of course, the person running the game does not have access to the server code. All right. If, based on our discussion right now, those ideas, you have to make some changes to your design document, or you're still thinking about it, you can turn it in tomorrow. There won't be any penalty if it comes in tomorrow. If you're just forming up your team last minute, you can still do it tomorrow. That being said, due progress is due today. And the progress may be that we haven't made any progress, but you need to go to that survey on Canvas and make sure you click in your details. Okay, questions about your final projects? Okay, the other thing, and I would say this to senior capstone, I'll say it to you, is your design doc is sort of like a nebulous promise of this is what you're thinking of doing. If it turns out that you say in your design doc, we plan to make Fortnite using JavaScript, and it turns out that that is too ambitious, we're not going to hold you responsible completely to that. We will, as long as you do good work towards whatever your goal is, we will be happy with that. Okay, so we're going to continue talking about Pixi, and those of you who have your laptops up should go to this website, www.csu.edu/CS-4540_examples, and we will look at some of this Pixi code. Yes?
I do have a question on the topic of the design document. As far as if we set out goals and we realize we can achieve all of them, do we need to add to our design document if we just had to have more things, or are we later on down the line?
Right. I'm expecting, this is a CS class, you should probably be spending about 8 hours a week on this project. If you get everything done in 2 weeks, you should find something else to do to add to it, right? That being said, if you're really amazing developers and you get this fantastic thing done in 2 weeks, and then you just pretend that you work for 2 more weeks, we probably won't notice when we grade it. But yeah, I mean, this is a chance to do something cool. Just take your opportunity to do that. Okay, so on this website, if you click on the Connect 4 link, you will see that there's a whole bunch of versions. And so we started our version, I'll go there, so we make sure everyone's on the same page. www.csu.edu, domain, examples, click Connect 4 examples, and there's all these different versions. And we started seeing the different versions. We got to something like here where we click on a checker, the checker would fall. And just to recap, checkers are objects, class checker that extends the Pixi graphics. A Pixi graphic is an object, a GUI object that allows you to draw or paint on the screen and then move and give commands to the object so that it does interesting behavior. All right, so version 4, we had just started writing buttons, and so our buttons look something like this. Again, a button is a JavaScript class that extends Pixi graphics, and it just draws a rounded rectangle on the screen, and if we click it, it has a click handler, so notice that the mouse goes over it, it says it's clickable, you click on it, and it creates a checker that falls on top. And that's all that's going on. So here are all the files that we have right now. The checker didn't change, the setup didn't change, the main didn't change, button looks something like this. So again, we're extending Pixi graphics. Just as in normal classes, you have to call super, and almost in every GUI hierarchy, you always have to say super to initialize the GUI elements. We're interactive, we're a button, which means the hand goes over it. We keep track of which column we're in as part of our class. And then we talked a little bit about, like, how do we declare fields inside of a class in JavaScript? So looking at the syntax, interactive, button mode, and column are all fields. Where do those fields belong? So where does interactive belong? What does that belong to? I'll give you 3 hints. It's built into JavaScript. It's a base level object thing in JavaScript. 2, I defined it somewhere. Or 3, it's part of Pixi. All right, how many people think it's built into JavaScript? How many people think it's Pixi? And how many people think I defined it? A lot of people did not raise their hand at all. Interactive is built into Pixi. Okay? Button mode, where the hand goes over, that also is built into Pixi. Column, so the fact that this button is part of a Connect 4 game, how many people think that is built into JavaScript? If the designers of JavaScript thought Connect 4 was the thing that everyone would ever, and they put that right in there. No, obviously not. So how many people think I defined it? Okay, good. You all got that right. I defined that one. How can you tell? No one. How can I tell?
It's up there in the comments.
It's up there in the comments, yeah, with the misspelling too, yeah. It's in the comments, that's right. Any other way to tell? Well, the answer is there's no way to tell. This is JavaScript, it's a scripting language. What's amazing and terrible at JavaScript at the same time is if you want to add data to a class, anywhere in the code you can say this dot, come up with whatever name you want, and give it a value, and you've added a field to your class. So I can go way down here where the button is clicked and say this dot Jim is great equals true, and all of a sudden Jim is great would be a variable that's part of this class. So with any scripting language, it's up to you to be really careful because it's so easy to make all sorts of hard to read and hard to maintain code. So one thing that we should do is we should take column and we should define it up above our constructor. That would be something that would be better because then it's easy to identify. Remember we saw that you can define things at the top? Let's see if I did that with checker. Checker. I did not do that with checker. We'll see that at some point, but you can in fact define right up here, you could say column equals 0, and that will tell you that it's this dot on mouse down, do the button click, and the button click function is right here. One of the neat things is here. Notice I use this dot button. How many of you in Java or C# use the keyword this throughout your constructor? Why? Why do you do that?
Because it makes things easier to read.
It makes it easier to read. Does the computer care?
No.
Computer does not care at all. In JavaScript, computer cares. The this is not only nice, it's required. If you take the this off, it will say, I don't know what button click is. And so it's very important to know that whenever you want to access anything in the class, you always put this in front of it. So is check part of the class? No, why not? Because there's no this in front of it. Okay. All right, so let's look at the button click. Here, whenever the button is clicked, we create a new checker using the same syntax you would in C#. We tell the game controller that it's the next player's turn, so we have this game controller object. And we set the location of the checker. So this is another interesting thing about JavaScript, for most part, there's no public and private, but we have seen now that there is. Well, Pixi was built before public and private, so you can just reach into your checker and access the X or Y. You can reach in and access the scale. In both of these cases, we place our checker somewhere on the screen and we scale it to half the size because we do it big and then we can scale it to any screen size that we want. Then we tell the checker to begin its fall animation in whatever column that is, 7. And we always in Pixi have to take our object, our GUI object, and add it to the stage if we want it to show up on the stage. So every time you want to put something on the screen, you have to either add it to the stage or to add it to something that's already on the stage. And then finally, we had the draw program. Here, all we did was set a fill color, draw a rounded rectangle, and fill it, and that's what draws it. We call this once at the beginning of our program, and that gives us our nice little rectangles. Okay, and then this is what we've got. So we click on these things, and down. Oh, 7 is the row that we're falling to, not the column. So we're falling to row 7, and every one that we click falls to row 7. By the way, how many checkers are on the screen right now? You might say 3, but it turns out that there's dozens because I clicked that button dozens of times. Just because they're hidden from your view doesn't mean that they've gone. And so if we kept doing this, eventually we bloat our memory and the program would really slow down. So if you reset the game, you would want to get rid of those checkers. You know, remember garbage collection in JavaScript is the same as in Java or C#. Okay, so the next thing I did was add gaming to this. And so we come down here. We have a game controller, so we move the checker creation in the game controller. So the game controller is going to become more of the main part of the program. And then we keep track of the number of checkers in each column. So what does that look like? Okay. So now, when I drop a checker in this column, the next checker knows that it goes above, and the next checker knows that it goes above. So what data structure do you think I used to keep track of how many checkers are in each column? What's that? One vote for double array. Any other votes? Data structure. Keep track of how many checkers are in each column. An array, or dictionary. Okay, we have an array and a dictionary. Dictionaries could work, but array, why array?
Because you can define amount spaces in each one and just like put Boolean value and like check them.
Okay, we could define the space in the array, yeah, and
Couldn't you just do a 2D array that represents the whole board?
could we do a 2D? Yeah, this one was suggested here, a 2D array that represents the whole board, right? Well, in this case, all I need to know is how many checkers are in each row. So there are several. We could use all the above versions, but I chose to use a single-dimensional array that starts with 0, 0, 0, 0, 0, 0, 0, and when I add a checker, I increment the value to 1, and then increment it to 2. So very straightforward data set. So let's look at the code for that. So here's my game controller. Notice that JavaScript has what are called getters. And you're all familiar with getters, but the syntax for a getter in JavaScript is slightly different. You have a get in front of the name of the variable. And then when you use it just like a variable, just like a property in C#. The game controller is a Highlander. That's an inside joke. How many people get it? Oh, look, there's a few people who get it. Oh, that's sad. So Highlander's an old film about these guys who battle with swords, and they're immortal. They live forever, except that they chop each other's heads off. And so at the very end, there can only be one Highlander left. There can only be one. So this is a singleton. You all know what singletons are, right? Yeah, only one. You can only have one of these, so Highlander is a singleton joke. Okay. Anyway, here is my board. It's just how many are in each column. Next player's turn, we simply swap whether it's black's turn or red's turn. We have a getter that returns if we want to, if it's black's turn or red's turn, so get black's turn. Anybody know what the underscore P stands for? Any Lisp programmers in here? No. P does not stand for pointer, it's a good guess. You might have talked about this in, say, 2100, 3100 logic. It's a predicate.
Oh, okay.
It stands for predicate. Have you heard the term predicate before? It means true or false. So in nice languages, what does the P become? The P's been moved to a different character in nicer languages. What? Not a B. Drop in the air. It's not a Q. I'm doing excited. It's a question mark, yeah. In C#, you can put int question mark, which means this may or may not be an int, right? It could be null or not null. Okay. So plain column, we simply check to see if there's room left in the column. If there is, we add one to that column, we build a new checker, and then we add it to the stage. And one of the really nice things about the checker is just by adding it, we add it there and then we begin the fall animation, and as soon as it's on the stage, it just falls. Our job is over, we don't have to keep track of that animation. So putting the animation inside the checker class is really easy for a maintenance point of view. Okay, and then this is the main program where we build our stage, we build all of our buttons, and we add each button to the bottom of the stage. So nothing exciting there. Please, by the way, interrupt if you have questions because we're going over a lot of it. For the most part, though, it's straightforward coding, but it's new Pixi. You know, you guys haven't seen Pixi.
Mm-hmm.
Okay, so then we go back and look at the column field alert. So all this does is if I fill up the column, it's going to say the column is filled. And this is it's a pretty neat little animation. I'm sure you've seen it on lots of games where you do something and you want to pop up a message, but you don't want it to stay on the screen. So how would we do that in Pixi? Well, we need a Pixi object. Turns out Pixi has text, so we're going to put a text up. We already know that we can animate things, right? So we're going to animate it.
Mm-hmm.
Did you know that you can make things transparent? Maybe not. Well, it turns out you can make things transparent, so we're going to animate the transparency until it goes away, and then we're going to remove it from our stage. So let's see how adding that code looks. So here's our warning message. First thing I'm doing, I just stole this from the Pixi website, is a giant definition of a style. So this is Arial 36 font with fills and strokes and shadows. Way too overcomplicated, but it shows all the many of the things you can do with text.
Mm-hmm.
Okay, so warning message is a Pixi text element. We pass in the message that we want our text to be and the style element. So again, the style is defined up there. We are going to count down from 60. So who remembers how long 60 is? There will 1001, 1002. 1001, 1002. So how long is 60?
Yes.
It's approximately 2 seconds. It depends on the frame rate because every tick, every animation is going 1 frame of your program. And usually we're trying to do 30 frames per second in a web-based game.
Mm-hmm.
If you're doing a real game with a real first-person shooter or something, you'd want 60 frames a second or higher, probably. Or at least that's what my son tells me. Okay, what happens? We are again using this ticker class, which is what we use for all our animations. We add this object's fade function to it. And the fade function does the following. It just counts down 1 of our 60 The alpha becomes the countdown divided by 60. So alpha is a number between 0 and 1. That's how transparent it is. And if the countdown reaches 0, we do two things. We first remove the animation ticker, and second, we remove the item from the stage. So these are cleanups. If we don't do these, it'll turn invisible, and the alpha will keep getting negative. But in the background, every time we'll be updating this useless piece of memory waste. So we have to get rid of it from our project. That's it. This is all it takes to pop up something on the screen to give a message. Now you can imagine lots of games where you have little messages appear above characters' heads or messages that appear up and fade. This is the standard appear and fade message. Questions? Yeah?
Is it the alpha that is the function of the fade for the text?
So the question is, what is this alpha doing right here?
Yeah, is that the part that's making the text a bit fade?
Yep, alpha is how transparent it is.
Okay,
Yep.
yeah.
And it is built into Pixi, so it's a part of Pixi's object, not part of my object.
Mhm.
And simply by changing its value, you change how transparent the thing is.
Right.
Okay, so that's a pretty straightforward piece. The next thing is the board overlay. So we have this column. It's looking a lot like a Connect 4 game, except the board is invisible. And so why don't we add a board? So there, now we have a board. Well, how hard is it to create this board? Two options. One is you could get an artist friend to draw it and save it as a picture and then just put it up there. That would be easy.
Yeah.
The alternative is to create it with code, which is what I chose. And it turns out Pixi has a very nice function now that allows you to chop holes in a shape.
Okay.
Yeah, how do you chop holes? Drawing holes is easy. Chopping holes is hard.
Yeah.
And in the old days, like the last time I used Pixi, you couldn't even do it. But it's such a useful feature that they've added chopping holes into it. Now, when I first built this, I wrote the code and I just randomly guessed at how far to put these things across. And so, as you might guess, I ended up with circles overlaying like the outside of the board. And what happens when you try to chop a hole in something but it's not a hole, it's sort of sideways. Anyway, it caused the whole thing to explode in weird lines and stuff. So let's look at what this board overlay looks like. And again, I want to stress how this should be showing how straightforward Pixi is, because again, class board overlay extends the graphics. All we're going to do is draw ourselves. We draw the big rounded rectangle. And then we use this thing called begin hole. We draw a whole bunch of circles. Because we're inside of the begin hole, those circles no longer draw. They just cut things out. And then we end the hole. So the only exciting thing here was writing two nested for loops. Oh wait, that's not exciting anymore. Don't do that. Coming up with the math to calculate where I wanted the pieces on. So that's it. Yeah.
So does the hole also take care of the outline, like the black outline?
If you look here, up there I set line style to have a 3 and an outline. That line style, because I haven't changed it anywhere, falls all the way through down in here, and so those circles that are being cut out also have the outline. Okay, so now with only a couple added additions, you can play Connect 4 with your friends. The only problem here is the following.
You should have won already.
Who won? Block won, obviously. They have 4 in a row, right? So winning is probably something that you would want. Most people expect the computer to take care of win conditions. All right, but before we get there, I'm going to add a couple more things. A reset button. So now when there's a bunch of stuff on the screen, I want to play a new game, I'm going to reset. Reset. Okay, so how does resetting work? Well, what's the algorithm for resetting the board? Who wants to take a guess at it? What do you think?
I think it's going to redraw everything. Like just redraw the background, the buttons.
Okay, so the comment down here is the reset's going to draw everything over again. Okay. That might be true in the old days, but Pixi is taking care of everything for us. We don't need to redraw because the outline, the buttons, they're already there. Don't need to redraw them. Pixi is constantly redrawing them, making sure they're there. All we need to do is get rid of the checkers, right? So how do we get rid of the checkers?
Move them up.
We could move them up here. You could hide them, but you don't want to hide them. You want to get rid of them. Where is every graphical element in Pixi? It's on the stage. Everything's on the stage. So if you take them off the stage, they go away. So let's look at what the reset looks like. So if we go to main.js and look for the reset button, here's the reset button. So we're going to create a new button, and I'm reusing the column button, so I have to give it the column it's in, but it's not really a column button. So this is wrong. Like, I didn't want to rewrite a button code for this button because I already had button code, but my button code was only for columns, so now I'm sending in this -1 to my button for resetting, which doesn't mean anything. So I need to re-architect my systems. But I'm not going to do it right now. I'm just going to reuse this code because we're all hacked. We all hack our bad code and keep using it until we pay a price, and then we redo it. Okay, so we put our button up. On mouse down, we're going to do this function, and then you see warning. This relies on the fact that checkers are placed at the beginning of the children array of the stage. So every time I add a new checker to my stage, it just goes on the front of a linked list or a list of objects. And so here's this really cute thing. I grab the sprite that is the first child of the stage, so get the first thing that's on the stage. This could be the board. This could be the text object. It could be anything. But because I know I'm placing checkers on the stage, I'm pretty sure it's a checker. And I say, if the sprite is a checker, remove it from the stage and get the next first thing on the stage. And then it just keeps looping. As long as I keep finding checkers, I keep popping them off the stage. And simply by removing from the stage, they disappear. They're no longer gone. And so that's the entire reset. Oh, and there's my board array after I reset it to 0, so there are no more checkers. When I first did this, I forgot this part. And so I started dropping new checkers, and they were floating above the old checkers, which were gone. So that's it. That's the entire reset algorithm. Now you're going to use this in a second because I'm going to give you, as a group, we're going to actually play with this code. So you just have to stop listening to me in a few minutes, and I'm going to ask you to add a neat thing to the reset. But not yet. Okay, so let's look at a few more things. Ajax. So I already know how to do Ajax, but I want to show that you can do it in terms of Pixi. I mean, just because it's an animation game doesn't mean that it can't have Ajax calls. So what's going to happen, you see that play button? When I hit the play button, it's going to send a request to the server saying, hey, give me a move. The server is going to calculate the move, send it back, and then we're going to play that checker. So watch carefully. Ajax called the server, and it was played. And then we can just do this until, oh, you notice it said call and fill because it doesn't know what the board is. It will keep playing, and there, it filled up the board. All right. So that's pretty cool. We have hidden the logic and the AI inside the server. We make calls to the server to get the next move and replay it. So what does that look like? Main.js. So let's go into main, and we're going to look for Ajax. Okay. So here I add the play button. Again, it's another button, and I locate it. I call Ajax. I send it to the get move controller. It's a get. I pass in the board so that the controller can see what the board currently looks like. And when it's done, the location is sent back to me, and we simply play in that location. If we look at the buttons that normally are clicked, they are also calling game controller play in columns. So the only difference here is the AI is calling game controller play in columns. That's it. Standard Ajax that we've seen in our past assignments. Questions? black checkers are great, but why can't I just go on the internet and steal somebody else's checkers? So if you look carefully, these actually look like images of real checkers that I stole from the internet. But I can do that because it's education. If you did this, you would probably want to make sure that you had the rights to use those checkers so that if you made money from this game, someone couldn't come and take your money away from you. Okay. How hard is it to put images on checkers? Like, did I have to rewrite everything to deal with images and pictures? And the answer is no, I certainly did not. Let's go look at our checker.js. And I've added an add image. Okay, so what does add image do? It says, if you're a black checker, call Pixi sprite from red.png. So I have a PNG image on my server, and I simply ask Pixi to go grab it. And then if I'm a black checker, sorry, oh, that's weird. It's an error in the code. If you're a black checker, you put red. If you're red, you put black. It turns out because it's binary, it doesn't matter. No one would ever have found this out. I'm sure that some really subtle plug is going to be spending hours and hours trying to find that. Okay. That being said, everything else is the same. I still, I scale the image. So usually your images are bigger than what you need. You can have the artist directly make them the size you want, but usually you want a bigger in case you want a bigger image. So what does this do? This dot radius divided by this dot image width divided by 2. It's math, so it'll take you a while to figure it out. Maybe. All right, so what is this dot radius?
Radius?
It's the radius of the checker, so how big you want your checker to be. The width divided by 2 is the radius of the image, and if you divide the 2, that gives you the scale factor to scale such the image shrinks down on top of the circle. That's all that's doing. Now, when you first run this, it doesn't work. What does he mean by that? Let me tell you, this is really cool. When you first run this, it doesn't work because when you say get sprite from this PNG, where is that PNG located?
On the server?
On the server, right. Yeah, the image is not on your laptop, it's on the server. So how long does it take for this line of code to load something from the server? Who knows? 50 milliseconds, 100, 200 milliseconds? How long does it take the JavaScript interpreter to go from this line of code to this line of code? Less. So at this point, the image does not exist because it hasn't been loaded, and so the width is 0, which gives you some really weird behavior. Now there are 2 ways to fix this. When I first saw this, it's like, this doesn't make any sense. There should be something special about this line. What should be special about this line? Bonus points if you use the word async in your answer. Go ahead.
You have to wait, make sure you wait for the image.
Yeah, you need to wait for this to happen. Well, it turns out that loading it does not wait. And so it keeps going on. But that's what you need a wait, just like in C#, a wait here. You don't have that. So what happens is the following. How many of you have played a game on the computer and you see a loading bar at the beginning of your game? Oh, you've surely seen that, right? Well, what's happening there is you're loading all the assets, the music, the images that the game needs. Pixi does the same thing, and so in our main program, we have to do the following. We have to grab a Pixi loader object, and we tell the loader, hey, loader, I'm going to need this image and that image, and when you're done loading everything, call this function. So we are going to preload our images into the environment. Once we are done loading our images, then we go on and we make our stage and everything before. So now the next time that you say I need that image, where does the image exist? It's now on your browser. Yes, it's cached in your browser instead of on the server. And so by using a loader, we get rid of this problem with having to get all our assets onto our computer before our game starts. Okay, but in case it wasn't clear, with that side note about loading things, this is all it takes. You say, "Give me an image," add the image to the sprite. That's all. If you want an image onto the browser Pixi stage, you just add it to your sprite, which is on the stage, and there you go. You're done. All right. Couple more things, and then we'll play. So it's really interesting. Like, mobile is really important. So if you have a mobile device, go and bring your mobile up and go to that website. Okay, so here is my website loaded on mobile, and here's me dropping things. Does everyone see all the checkers falling down? No. It's sad. Because you would expect it to work on a phone, just like it should work on a computer. So the problem is, all the buttons are using an event which is called pointer down, which is basically clicking with a mouse. Turns out that when you touch a screen, that is a different event. That is not a mouse click, that is a touch event. And so what we need to do is reorganize our program such that we can use touch events or mouse clicks instead of just using mouse clicks. So let's go look at checker.js. Oh, sorry, it's not the checker you're clicking on. I need to go look at the button. Okay. So that used to be on mouse down. So I changed it to pointer up. Pointer means both the mouse and the touch. So that one line change changes it so I can now play it on my mobile device. Pretty nice. Also, I changed it from down to up. Why did I change it from down to up?
Because the event is triggered once you...
Yeah, the normal way things work is buttons don't trigger when you press them. Buttons trigger when you let go of them. Yeah. So that's all changed. If you want to use mouse events, if you want to use touch events, if you want it mobile activated or on your desktop, you just use pointer instead of mouse and everything works. So that's a pretty easy change to make. And let's verify that. So this is version what? Version 11, mobile. So I'm going to go to version 11. And here is my stuff. And now if you're watching, you can see that I in fact can play on my phone. One of the nice things I like about Pixi is that it deploys on both desktop and mobile, just like that. Okay. Two more things. Let's just do one more thing. Sound. So sound is pretty cool. You'll notice that I am using a checkbox HTML element. So there's two nifty things here. One is I could have a control panel that allowed me to mute in Pixi. So I could pop up a window in Pixi and put buttons that say mute or unmute. But HTML already has a whole bunch of nice little elements for doing things like checkboxes. So it's certainly possible to use the HTML elements and link them to your Pixi game rather than do everything in Pixi. So for example, if you wanted people to type in their high score, you could build a widget in Pixi that would allow people to type in their name and get a high score, or you could do it in HTML and then attach it to the game. And it's sort of up to you. So I want to show you can do both. Okay, so here I'm going to mute, unmute, and then play some. Maybe. Why do I not much sound. Why do I not sound? Someone else go to this webpage and see if you're getting sound.
Yeah, there you go.
Good, play it loud. Why is this not? Yeah, good. It's not muting? Okay, well, I don't know. Hit the reset button real quick. Alright, okay. So, sound is a huge part of any game. How do you do sound? Well, first of all, you need to have sound resources. So here I have, now I've created a folder now called resources with my images and sounds in it. And everyone click mute now. And so then once you have the sound in, we're going to use the Pixi sound library, which handles all sounds at a very high level, which makes things very easy for us. So we're going to go to main and our loader. So again, we are going to load our sounds at the beginning of our program. And then once our sounds are set, then all we have to do is find where we want them. So in the I think column button is where we have some sound. Yep, this is it. You simply say, hey Pixi, I want the sound library to play the bell or play the chime, and that's it. You just call play the sound and the sound comes out. Likewise, if we want to see the reset, so if we look at the reset and I want to play that fanfare, I just say Pixi sound, play fanfare, and whenever anyone resets the game, it plays that. So the only thing that's missing here is the this mute button. How does that work? So let's take a look. So where's our mute button? Okay, so here it is. It's a checkbox with the name mute and ID mute. And in our script, let's go to our main setup. Well, it's not in main. Do I put it here? Oh yeah, it's in this startup. So when we start, we are going to, the first thing we're going to do as we start our game controller, we are going to mute all the sound because we don't want the sound to be playing all the time. And then we say whenever the mute button is clicked, call the mute function, the mute checkbox. And here we say if the mute checkbox is checked, we mute all, and if it's not, we unmute all. So those are our two commands. It's how we tie a checkbox to our Pixi by just putting the Pixi code directly into the JavaScript that's associated with the checkbox. And then mute all and unmute all are great. What's really powerful here is you could have tons of sounds playing in the background, long music riffs, being buzzes, and as soon as you say mute all the sound stops. So in the old days, you actually had to go and find every one of your sound units and turn them off individually. Here you have the mute all functionality, which Pixi Sound does. All right, so all that put together gives us a playable game of Connect 4. So what I want to do is now, yeah, go ahead, question.
With the mute all function, does it keep playing in the background or are they stopped?
The question is mute stop, and I think it depends on whoever implemented it. Pixi said mute does not mean stop. Mute means it's not, you can't hear it, but it's playing, so it's still playing in the background. Okay, I would like you all to pair up in groups. Anyone who's got Visual Studio relative to go, here's a Connect 4 zip that has a project in it with Connect 4. And you can load it in Visual Studio, run it, and it should look just like version 13 of our program. And I'm going to give us about 15 minutes to do the following. So we're going to add what's called a fancy reset. So let me put a bunch of checkers on the board. The fancy reset is going to look like the following. So instead of just they go away, so there's all our checkers, and they just fly off. Okay, so what do you need to do? Get together, find the reset function. In the reset function, you need to take every checker and make it fly away. Okay. How are you going to do that? Well, I want you to form groups of 3, grab that code, and we'll spend about 15 minutes playing with it, see if you can do that. So if you're not sitting next to someone with a computer open it, go sit next to someone with a computer.
I'm half inclined to just jump in.
Right. Start working on the game.
Yeah.
It's definitely going to be a lot of coding now. A lot of coding. Think about it, like just our games, or if people are working in games, I don't know what you guys are doing. Okay, that's awesome. Yeah, not too. I doubt it.
It is, yeah. We're going to use an open source thing called charts.js to make charts and stuff. Totally separate from Pixi, so I can
To me,
I didn't see that, no.
this is really cool. Because I know it's like against using Unity. Is it what? Unity?
Well, Unity is a game. Like,
You can build browser games. That's pretty good. You would know.
I'm trying to think, like,
And that's hilarious that you're EAE and you're creating I would have thought you would have been
well, we talked about it. Chris is already, you're already already making 2 games for other classes. So
oh my gosh.
Why throw a third?
Yeah.
Well, I haven't done any online.
Okay.
So, I mean, technically it would be probably the same as with that web sheet thing.
Yeah.
So it would be kind of like that where it'd be a zooming cut thing. But, I mean, you can do something like that. I don't know about, like, making it
Right.
back when I did 3505, we used to use box 2D. We talked about that here.
No.
Like another like physics engine that like determines collisions and stuff. And it was just, it wasn't bad, but it also just took a ton of time.
Yeah.
And so, that was another thing I was thinking of. That, well, we're sort of avoiding looking at actually making the imaginary boxes line up where you can make stuff. So it would be,
I'm just trying to start it, see if we can even
In the reset logic. And what is this doing? It says for every row, for every column, I am going to look and see if my two-dimensional array contains null. If it does, don't do anything. If it doesn't contain null, what's in my two-dimensional array if it's not null? Checkers. This contains checkers. So if you didn't figure that out, this contains checkers. And so if I want to do something with a checker, I would do something like the following. This board ij dot fly away. Okay. So if you added a line like that that said, hey, let's make this checker fly away, you did very well. This is the place where you would put that. Okay, now the question is, what does fly away actually do? Well, my other hint was go to the checker JavaScript. So let me go to the checker JavaScript. And there are several, there's the fall method in here. So begin fall animation is 1. And then there's also the rotate animation that we saw when you win. So rotate turns out to be easier because all it does is say when you want to rotate, all you do is call this function. So what did I call my function? Fly away. So I'm going to come down here. I'm going to copy this code and say fly away. Leaving a console log would be great if I was going to debug, but I'll just get rid of that. And then I need to do something, rotate, I don't want to rotate, I want to fly. Okay, so then the last thing I need is a fly function. So here we could do this.x plus equals 1, something like that. How does animation work in Pixi? By changing the x value of something, it moves. If you do that over and over again, you have animation. So if I didn't do anything incredibly bad, and you would have told me if I made a typo, right?
You got one right there.
Got one right now.
And you're not telling me.
No, I just
All right, where's my typo?
to fly me.
Thank you. Okay, so we'll run this. Connect 4, everything loads up, play, 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 and I hit reset. Everything went away. Okay, so let's go back to our code. And this is the tricky part because there's actually 2 reset functions. So I'm going to go to the main and find the reset. There's my reset button. So this is the one that would have taken you a while to track down. Why did they all go away? What is this doing? And what is this doing? We already went over this earlier. What does this loop do? It finds every checker and it disappears them, right? So if they have animations, they might still be animating, but they're off the stage. You can't see them. We don't want them to immediately go away, so all of this reset code is gone. Right? So we're just going to get rid of it. Reload, play some, and hit shift reload, play some, and hit reset. Whoa. They're all, that's all it took, so we don't get rid of them.
Oh, I just noticed red and black.
In our logic, right before we get rid of our object out of our board, we tell it to fly away, and inside our fly away code, oops, where's my fly away code? Inside my fly away code, we simply move it out. So these lines of code are the main things that we're looking for. Now, a number of you very aptly said, hey, flying, that's sort of like vector math, like linear algebra. Why don't we add some vector math? And so you said, let's have a vector. Well, this is the neat thing about JavaScript. If I want a vector, I do the following. This dot vector x equals 5. This dot vector y equals 5. Now the checker has a vector. I don't have to go anywhere. I don't have to define it anywhere. I can just magically write in this tiny piece of code, add fields to my class. Now, this could cause problems later on when people are wondering what these are for, but in this small example, it's probably worth doing. And then down in the fly, this dot vx and this dot y plus equals this dot vy. Reload. Put some checkers on there and reset. And they're all off. Now the other question is how to make them go in all different directions. What is the JavaScript random number generation?
Math.random.
Is it math.random? Someone Google it for me. Is that it? I can Google as fast from you. Math, random, integer, JavaScript. Math.random.
So yeah, got it.
And then you have to round it up or down. Math.round. Oh,
Yeah, you're missing.
good. Let's see what happens. Shift reload. Play a bunch of these things. Oh, we already won.
Oh, weird.
So why are they all going down? Because I don't have any negative values. So many of you are already thinking that I should put 5 minus in front of this, and you are absolutely right. And so reload this thing. And then reset it. Wait. I did something wrong. I just made a typo. Let's try this one more time.
You want to do 2.5 instead of 5?
What's that?
You want to do flat 2.5 minus
Thank
5?
you. All right, something like that. Okay, anyway, now there's one last thing. The problem is these things will fly forever, and so what do we need to do? I know some of you told me to do this already, so you can tell me out loud during the class. What do we have to do? These will fly forever. We don't want them to fly forever. Yes?
Added some sort of check that checks on the size of the board. So if you have 1,000 by 1,000 board, check to see if the X parameter is greater than 1,000, Y is greater than 1,000, or less than, I don't know, negative something.
Y is less than 0 bad here.
What's the center of the board?
Anyone have a guess why less than 0 is bad?
Because it's going to take away your checker before it actually goes all the way up the screen.
Yeah, once my checker is halfway off the screen, it will disappear, which sort of defeats the nice, beautiful look. So we'll just do something like -100. Okay, so now we need to get rid of. Now we need to get rid of the checker from the stage. So we have app.stage.remove. And this, that will just get rid of ourselves. Now there's one last thing. This will take us off the stage. This does not keep us from animating. So if we're going to stop us from animating, how do we stop from animating? Well, how do we start animating? That's how we started animating. Actually, this is how we started animating. So how do we stop animating? Uh-oh. An uncaught error. Stage.remove is not a function. This is a problem without a type check language. So if we had a type check language, it would have already told me in the compiler that I had misspelled this. But because it's not typed, we have to either know, in this case, remove child instead of remove, or we have to go and Google what's going on. The other thing is, notice all these things are behind the stage, which is fine, but maybe you want them to be in front of the board. And so how would you do that? Well, I will show you. Turns out this is a little trickier. It's a half. We're going to do app.stage remove. So app.stage remove child this. App.stage add child this. What does that do?
Is it just redrawing the checker, which then brings us to the front?
Doesn't redraw anything. So remember, the stage is just a... Pixi is doing all the drawing for us. Pixi has a giant list of objects, and every animation, it draws every object for us. Removing child takes it out of this list. Adding child puts it back in the
So
list.
it's just putting it at the front of the list.
It's putting it at the back of the list. And what order are things drawn in? From the front of the list. That's right. So by taking it out and sticking it in the back, it now will be in front of anything. Most languages have like a move front or something, but this is a cheap way to do that. Okay, so now if we've got everything right, if we reload, we play, we put a bunch of checkers on the board, and we set. They go everywhere. What have we just discovered?
Random number is actually zero.
So you should all feel almost, well, actually, we rounded. So I was going to say you should be blessed because this is a 1 in a billion shot, and your chance to win the lottery just went away because you solved it. But it turns out this is not 1 in a billion because we rounded it. It's 1 in 25. So 1 in 25, what happens to delta x? Well, 1 in 5, delta x is 0. 1 in 5, delta y is 0. 1 in 25, both are 0. So when will this checker go away? Never. So these are one of the things that you would probably not have checked, and if you never got lucky while you're debugging, you would hand this code in, and then the TAs would run it, and this would happen because your luck's really bad, and then they would take off points because you did not think of this error edge position. Okay, so how do we fix that, by the way? Anyone have good solutions to how to fix it? I need 3 more minutes. Yes?
If 0, set this.
If both are 0, randomly choose again. Terrible, but I've hacked. I've done that myself. Another idea?
Math.max. That way you never get 0. You'll always have a number that's higher that it'll max to.
Yeah, but then we're subtracting it, so we go back, we go left and right. So that's not going to work there.
Add 6 instead of 5.
No, it's still get zeros.
Just normalize your vector coordinates.
Normalize your vector coordinates.
Yeah, just like this.
So now we're going to get a division by 0 error. Because the vector's length is 0, so when you normalize that, boom. You could, instead of rounding, you could do it in floating point math. So instead of using integer math, you could use floating point math. Then the chances of getting 0, 0 are almost 0. It's still a bad idea. Any other ideas?
Just remove it after a certain amount of iteration.
Yeah, just have a counter after 30, throw it away, or a timer. Okay. All right, we didn't have time. I'm glad we did this. We're running a little behind. We have time to talk about AWS. I have requested an AWS educated account for all of you. So I sent them your emails, and they're supposed to verify that I'm a teacher and that we're legit. And then you should be getting an AWS educated account in the next couple of days. So if you get an email, that's what's going on. This is my first time using AWS Educate, so we're going to be filling this out. At the end of the day, at the end of the next 4 weeks, I'm going to have you deploy to AWS, but we're not going to do a huge amount of stuff with AWS. I just want you to get the very basics in. So if you get that email, you'll know why, and then on Wednesday we'll talk about how to use it. Okay. If you have questions, oh wait.